Hey, g'day, it's Prezzo here. Thanks for hanging out with me in the shed today. This is going to be a build video on a pneumatic drawbar for this Bridgeport milling machine, but this would work equally well for any type of milling machine that has a hex-headed bolt on a drawbar, which operates through the center of the spindle. Now, my old milling machine had a different system for changing tooling. It actually had a positive spindle lock down at the bottom of the spindle here, and you can engage that. And then it would have a hex-headed nut on the end of the drawbar, and I was able to use this little gadget here, which is called a spammer, and you could just simply put that on the nut, loosen it, turn it over, whack it with the hammer, and that would release the Morse taper 3 tooling that I had in the spindle. Now, of course, the Bridgeport has R8 tooling, and the spindle is a different hex on the end of it, and there's a different workflow altogether for removing the tooling. So the first thing you need to do is engage the brake on the Bridgeport head, and in high gear or direct drive the brake is totally reliant on the friction that you get. Now you can engage the back gear and the brake becomes much more effective when you do that, but often when I have it in high gear and I go to release the drawbar with this 3/4 inch spanner, you've got to be able to get it up on top of the drawbar, give that a whack, and loosen it, and then you've got to sort of go through the rigmarole of getting that to unwind, and even then the R8 tooling doesn't always want to drop out of the spindle. So you've got to go and find a mallet, give it a tap, loosen it, and it's a convoluted process that I don't like. So what I've done is I've purchased one of these little butterfly impact wrenches. Now you can buy these quite cheaply. They're relatively low power, which means that you can engage that, give it a spin, and you're less likely to damage the hex on the end of the drawbar or the thread on the end of the drawbar. But it's still awkward, and you've got to be able to get that up on top, and I've got to stand on my toes to be able to get up there, and you've still got to operate it. It's a nuisance. And the other thing is that I used to be 6 foot tall, or 180 centimeters, and I say used to because, well, as you get older, things compress. Sorry, that's just a sad fact of life. And in fact, my wife always says to me, "It's too short, it's too short." I think she actually means you're too short, but let's not get hung up on semantics, shall we? Alright, so you can sort of see why this is a bit of a pain, really. And if you're shorter than I am, or that sounds bad, but if you're not as tall as I am, yeah, it gets a bit annoying after a while. So this pneumatic drawbar build is nothing new or exciting. Lots of people have done this before, and there are plenty of resources on the web which will show you how this is done. So why am I bothering? Well, there's one difference in the way I'm going to do this, two maybe, and we'll share that with you as I go along. I am going to make the drawings of this available if you want to use it, but because it's a work in progress, I'll get this one built and then I'll modify the drawings, and then you can take them if you want them. So yeah, let's go and have a look at some of the materials and the process for getting this project underway, shall we? Right, we're looking at the top of the Bridgeport head, and this is a bearing retainer, and there are 3 ready tapped 1/4x20 holes in this bearing retainer. Now these are meant to be jacking screw holes, so you can actually drive these screws down here, and we'll lift that whole bearing retainer off and the bearing. Here's the end of the drawbar. It's 3/4 inch AF. And these are going to be the perfect attachment points for our power drawbar. And I had to work out what the pitch circle diameter of those 3 radial holes were going to be. One of the good things about having a laser cutter is you can rapid prototypes very quickly. And here's a laser cut disc, and I used this to work out what the pitch circle diameter was. Now I knew it was going to be in inches. I measured with a caliper across these screws just to get a distance from center to center. I got pretty close on the first try, and the second time round I figured it was probably 4 3/8, so I set it to that and cut that template, and it fits over there perfectly. So if you're looking to do this for yourself, write that number down. It's 4 3/8 or 111.125 millimeters. Okay, let's go and have a look at the rest of the parts. Whenever I start a new project like this, my first step is always to model this in 3D CAD, and that allows me to just see the general layout. I can work out overall size, I can sort of get a feel for what materials and fabrications and castings I might need. And if you're looking at this and saying, well, that's just a plunge woodworking router, well, pretty much that's exactly what it is. So instead of an electric motor up here, we've got the butterfly impact wrench, and it's carried on a carriage which is sitting on 2 springs. And this dog-leg shaped handle that hangs down the front here is going to allow me to operate this mechanism without having to reach up too high. Now, until I get the rest of this made and mounted, I won't really know what shape that handle needs to be. But that's the rough shape that I think it will need to be. So let's look at some of the detailed drawings and the individual parts. Now, these are 2 of the fairly crucial parts that I need to make, and these do require some accurate machining. So this circular section here is what screws to the top of the Bridgeport head, and this is what the butterfly impact wrench will be carried in. Now, I've chosen to make this with castings, but you don't have to. So if you wanted to make this entirely out of fabricated parts, if you're good with a TIG welder, you could probably build these parts up from individual components. Or if you've got ready access to lots of aluminium stock, you could probably carve this out of larger chunks of material. And that would work perfectly fine. But I'm doing it with castings. Now, I have 2 castings. So this one is going to be the part attached to the top of the Bridgeport head, and these bosses for here will carry the linear shafting that the whole assembly slides up and down on. Right, this part here is what the pneumatic impact gun will be fitted into, and there'll be a hole bored in here, and the impact wrench will be fitted into that and held in place with a couple of set screws. So with the impact wrench here, there's a paddle which allows you to get forward and reverse rotation out of the pneumatic motor. So you press one way, press in, and you get forward rotation, press the other way and you get reverse rotation. And what we need to do is to have some way of operating that remotely via a lever. So I made a pattern for another cast aluminium part, and this boss on top here will take the 12mm, or I think it's 12mm diameter rod, and it just needs to have a groove machined out of the back of that to fit over this sort of a hinge joint here, and that will get screwed onto that paddle, and the paddle itself comes out very easily, so you can remove that, drill the holes and fit it all up. Now, I also purchased 2 of these linear bearings. Now that's the number there, it's LMFKH16WUU, and these are relatively cheap on eBay. And from the same supplier, I was able to get this linear shafting that fits the bearings perfectly. And it's got a precision ground surface on the outside. I'm guessing that's some sort of a hardened coating on that as well. And I was able to get a meter of that, and like I say, it was relatively inexpensive for what you get. So that's going to form the up and downy bit that the whole carriage will press into when we go to operate it on the drawbar itself. Now, the only other thing I bought was this impact socket. Now, I also have the same size, it's 3/4 AF with a regular socket, and I still haven't decided which one of these I'm going to use yet. The thing about the impact socket is that it fits the impact gun really tightly and it won't come off. This one just sort of, I don't know, maybe it's just a cheap socket, but it just comes straight off again, so I'm not sure if that's going to be any good. The thing about these though is you've got the 12 splined internal component on that, which means that you've got a better chance of getting it to fit on the hex of the drawbar. With these you sort of got a 1 in 6 chance of getting it to fit. What I may do eventually is sort of chamfer that out a lot more, so that as it goes on it sort of self-centers and that will drive that drawbar left or right very easily. But yeah, bought that brand new. Like I say, this one I just had in my toolbox, but I think it's pretty worn out and pretty cheap. Now, this is where things get a bit interesting. What I need to be able to do here is to bore a pair of holes in this plate here, which bolts the top of the Bridgeport head, and I want them 90mm apart, 90mm centers. They've got to be 16mm diameter holes, drilled and reamed. And our linear shafting is going to be fitted into those holes, and I'm just going to slide it in and lock it with Loctite. But the important thing is that these 2 pieces of shafting are parallel and that they are, well, a given distance apart, say 90mm. I say, a given distance because it's not important until you go to make the other mating part. So this is what the pneumatic impact wrench is going to be attached to, and I need to have exactly the same centers on this particular part. So just say, for example, that was 90.1. As long as I make this the same, it's going to work. But there only has to be a couple of hundredths of a millimeter discrepancy, and this is not going to slide if you're using linear bearings. Now you could just drill these holes oversized and just sort of put really loose PTFE bushings in there or something like that, and that's going to work. It'll slide up and down, the springs will hold it up out of the way. You don't need to have the spindle of the pneumatic impact wrench aligned perfectly with the drawbar. It'll find its own center and it'll work. But I don't want to do it that way. I want to try and get a little bit more precise with my machining. So what I'm proposing is to make a jig that will allow me to drill these pair of holes in each part and get them aligned precisely. Now if you had a fancy schmancy CNC milling machine, it wouldn't be a problem. I don't have that, and I don't think I can rely on the DRO on my Bridgeport to get me absolutely precise. I might get to 100th or 200ths of a millimeter, but that's not going to work when you're using linear bearings. So I'm going to show you a machine that I've already made using the technique that I want to replicate here, and we'll see how that played out. Well, this beautiful machine here is a George Thomas designed tapping and staking tool, complete with the sensitive drilling head. I bought a set of castings with this many years ago, and the entire build series was described in the British Model Engineer magazine. And George Thomas was one of those people that designed workshop accessories and workshop tools for home DIY enthusiasts, and part of his mantra was to be sure that you could make nearly all of this machine on a standard 3.5 inch center lathe like the old Myford ML7. And although I used a milling machine for a couple of things on this machine, by and large all of it was done on the Myford style lathe. And the reason I'm showing you is that these two arms here are designed in such a way that the bores line up perfectly, and that's part of the versatility of the machine. So this tapping attachment here, the actual chamfer on the end of that chuck there, fits exactly into that bore. So if I lower that arm, you can see it pivots, but when I raise it up again, it just aligns perfectly. Same with the drill head, it lines up exactly with that bore there. And you can fit all sorts of accessories. This is actually a bush to take things like punches and rivet snaps, and you can fit anvils in this lower arm here and make sure that everything lines up. So yeah, wonderful, wonderful machine. And if you get the opportunity and you can find a set of castings for it, the build series I think was actually written as a book form as well. But in the old Model Engineer magazine you'll still find the build series. So yeah, wonderful machine, but I want to show you the technique that George Thomas came up with for making sure these bores line up without using any fancy measuring equipment. That's my reference edge, just for marking out, that's all. I'm not going to worry about the other one. Already found the approximate center here and scribed on the size of the bore that I want to machine in that. But we're going to do all of that in the lathe. Okay, I got that dialed in the 4-jaw chuck now, and what we're going to do is drill and bore this out for the pneumatic impact wrench, and I'm just going to face everything off. Now this is largely cosmetic. I don't know if you can tell, but this end of the casting is about 1.5 millimeters, maybe 2 mil thicker than this one. It's just a casting error on my part, but we'll make that look pretty and then we can move on. This is a bit interesting here. There are two different diameters on the end of this spindle housing here, and they're not machined. So these are just like die casting, and I run the caliper around the end of that and I'm getting two different dimensions. I'm getting a minimum, maximum, and what I'm trying to do is to get this hole, this bore, to match this diameter here, so that it will enter. It's not going to be absolutely perfect, but as long as that goes into that bore, I'm happy. And then we'll counter bore for this bigger diameter here. So at the moment I've got about 1.7 millimeters to go in this bore here, and I'm taking a spring pass after each cut and then measuring. So we'll come up to that 1.7 and see how close we get. Alright, well that's going in. It's probably a bit looser than I would want. So we'll cut that back to say 1.65. We'll go right through. Alright, that's actually quite firm. I was lucky there. And like I say, this bore or this diameter here is not particularly accurate. I can actually see where it's rubbing off the powder coat. So I'll probably just sort of touch that with a file, try and get those high spots off, and I think that'll be good. So now I need to get this other diameter, this slightly larger one. We'll get that bored out, counterbored, so at least we got a sort of consistent fit all the way along up to this shoulder here. So on my caliper here it's showing between 0.6 and 0.52 difference in diameter, maybe even bigger, depending on where you go actually. There's a radius back in here, which is probably affecting that measurement as well. So we're going to aim for 0.6, I think, yeah, about 0.6 over what we've got now. Okay, so I've set this to 0.6 over the diameter of the board that we've already got, and we're going in 7 millimeters. Alright, well that's firm, and you can probably tell by the way this is scuffed here that they are the high spots around that circumference there. I'm a bit reluctant to open this bore up bigger, given that this is not truly circular. So I think what we'll end up doing is just sort of dressing this with a file until we get a snug fit. There's quite a large radius in this corner here, so I'm going to take a big chamfer out of this edge of the bore so we can try and get the seat down relatively firmly on that end there. There you go, that's it. I wonder if it was just that chamfer that was stopping it. Anyway, happy with that. Just in order to hold this impact wrench into this casting, what I want to do is to get a single grub screw driven in to this bottom edge of that groove. Now I've modelled this up in CAD, and if I hit a point 6mm back from this face here on the centre line at a 30-degree angle, we can get the grub screw engaged on the bottom edge of that groove. So that's what we'll do. I'm going to mark this out, and then we'll drill this while it's in the lathe so I know it's on centre. So there's 6mm using a Jenny caliper. I reckon these are the most underrated tool in the home workshop. You hardly see anybody using them, but they do a fantastic job of being able to offset a measurement from an edge. So in this case, because I've got that chamfer there, I can put the bent leg of the caliper against the flat face and still get my scribe mark relatively accurate. So there's my scratch mark there, and we'll line up our center drill and bring it in on that 30-degree angle. So this is the setup I'll be using here. I've got this old 2-speed AEG drill set up in a fixture on my compound slide, and that aligns the axis of the drill bit with whatever the compound's set to. So in this case it's 30 degrees off the axis of the top slide with cross slide. And I've got a wiggler set up here in the chuck, so I've aligned that point accurately, and I can bring the axis of the drill into the line at that 6mm mark we've already put on the casting. So all we need to do is make sure that this reference edge here is now vertical. And I bought one of these little gadgets recently, and they're absolutely brilliant for doing this sort of thing. So we're just going to turn that on. It's already zeroed, and I can put that on the chuck jaw, and then we can just rotate the chuck, and there it is set at 0. Now I've got it in gear, but there's still a little bit of backlash there. I'm just going to have to hold that and get the drill bit started. Alright, it's going to be a bit of messing around here that you can't see, but I'm going to align that wiggler with that point, or that mark, and then we'll go ahead and drill. Okay, had a torch on that. I checked everything. As long as I don't move the saddle, we're good. So I just got to advance the drill bit using the compound only, and we'll stay aligned with that mark. Now we're going to tap that at M5, so I'll go and get the tapping size drill. Well, I don't know if you noticed, I'm sure some of you did, but that drill bit did deflect slightly. I don't think it's going to affect the overall fit of everything inside this bore here. Just slip this drill out of gear. And we're running the tap in and advancing the compound slide at the same time, just to get the tap started. Right, let's hope they come out in the right place, eh? Giving that casting a clean up, deburred everything, got the grub screw in there. So what we should be able to do now is push the impact wrench in and then tighten up that grub screw. And what it should do is bear on the opposite edge of the half round groove. and actually pull the casting up onto the nose of the wrench and lock that in nice and firmly. So that's all good. And just looking around the other edges there, it's sort of firmly seated all the way around, which is great. So that part's done, but we still need to bore our holes. Well, I'm sure you can tell that things have moved on from what I showed you last, but the reality was I wanted to be sure this thing was going to work before this first episode went to air. And if it didn't work, it was going to get binned and we'd say no more about it. But as it's turned out, it's great. I was actually really surprised at how well this aligned with everything else in the machine. So that part of it's good. Now in the next episode we're going to do the large circular disc that fits on top of the Bridgeport head. We'll get that drilled with its pattern of radial holes. We'll do all the bores and fit the bearings and see how that turns out. But I can tell you now, it works out. So I'm going to finish this video here now, and I'm going to wish you all a Merry Christmas and a Happy New Year. And believe me, I'm sure we all want 2020 to be done with. And when I catch you in the new year, we'll work on with the second part of this build. So it's Prezzo signing out for now, and I'll catch you on the next video. It's sad, isn't it? I haven't got a turntable.